This is the open loop transfer function. When you get a question like this, the first step to draw root locus is to locate poles and zeros. For getting poles, you need to equate denominator equal to 0. For getting zeros, you need to equate numerator equal to 0. First of all, we can find poles. For getting poles, equate denominator equal to 0. From this, we will get either s equal to 0 or we will get this term equal to 0. That is s square plus 4s plus 11 equal to 0. Here the power of s is 2. Therefore, there will be 2 values for s. How to find that? This is a quadratic equation. So we can use the formula minus b plus or minus root of b square minus 4ac divided by 2a if you are doing manually. Or you can simply use calculator. Then this is the calculator. Press the mod button 3 times. Then you can see equation. Then this is a second degree equation. So press 2. Then the coefficient here a it is 1. Then press equal to. Then coefficient here b it is 4. Then coefficient here c it is 11. So when you press equal to, you will get minus 2. But as you can see here, minus 2, there is a real part. Okay, this is a real part, minus 2. So minus 2. Then for getting imaginary part, press shift, then press equal to. You will get the imaginary part 2.64. So plus 2.64i. Now this is the x1. For getting x2, it is minus 2. Minus 2 is the real part. For getting imaginary part, press shift, then press equal to. You will get the imaginary part. It is minus 2.64. Minus 2.64i. Therefore, the values of s are s equal to 0, s equal to minus 2 plus 2.64, s equal to minus 2 minus 2.64. These 3 are the poles. Thus, we got 3 poles. Now, we need to find zeros. For getting zeros, what we need to do? We need to equate numerator equal to 0. When we equate numerator equal to 0, we will get s equal to s plus 9 equal to 0. From that, we will get s equal to minus 9. Therefore, our 0 is at minus 9. So we have only one 0, that is at minus 9. Now we need to locate these poles and zeros in our graph sheet. Our graph sheet will be an S-plane. S-plane means this is sigma and this is j omega. This is the real part and this is the imaginary part. Now real part, the poles. For marking poles, we will put cross mark. For marking zeros, we will put zeros. So first pole is at 0. So at origin, we have a pole. Poles are denoted by cross mark. Then P2, it is at minus 2 plus 2.64. Minus 1, minus 2. Minus 2 plus 2.64. 1, 2, this is 2.64. So at this point, we have pole. Then P3, it is at the negative part. Minus 2, minus 2.64. This is minus 2 and this is 2.64. So this part. These 3 are the poles. Now after marking poles, we need to mark zeros. 0 is at minus 9. Minus 1, 2, 3, 4, 5, 6, 7, 8 and 1, 2, 3, 4, 5, 6, 7, 8, 9. So here we have 0. Zeros is denoted by 0. So here we have a 0. Now here the graph is in S-plane. So in S-plane, this is sigma and this is j omega, the imaginary axis. First of all, write the scale. Scale 1 centimeter, it is equal to 1 unit. So in first step, we need to locate poles and zeros. So poles are at 0, we have a pole, then minus 2 plus 2.64, 2.564. So here we have a pole, then negative side also 2.64 here. So these are our 3 poles. Now we have one 0. The 0 is at minus 9. So at minus 9, we have a 0. So we mark the poles and 0. Now in step 2, we need to find the root locus on real axis. For finding root locus on real axis, we are going to use test point. Now listen, if we have even number of poles and zeros on the right hand side of test point, then root locus will not be existing. If there are odd number of poles and zeros on the right hand side of test point, root locus will be existing. I will tell you. Suppose I am going to place my test point here. Then on the right hand side, there is only one pole. 1 means odd. If there is odd number, odd means root locus existing. So therefore, at this region, root locus will be existing. Now if I am going to place my test point here, then on the right hand side of test point, there is only one pole. That means odd number. Therefore, my root locus will be existing. Like that, if I am going to place my test point here, On the right hand side, there is only one pole, odd number. Therefore, my root locus will be existing. Now listen, if I am going to place my test point here, then on the right hand side, there is one 0 and one pole. So 1 plus 1 it is 2. 2 means even number. If it is even, then root locus is not existing. Therefore, at this region, root locus is not existing. Then if I am going to place my test point here, then also 2 numbers are there. Therefore, my root locus will not be existing here. So my root locus will be existing only here. Now, by using test point, we found that the root locus is going to exist only in this region. So we need to draw root locus. We need to draw this line a little more brighter. Okay, we need to draw this line a little more brighter. Then we know that from poles the root locus is starting, and to 0 the root locus will end. So from poles the root locus will start. The root locus will start from pole and it will end at either 0 or at infinity. So by using test point, we found root locus on real axis. In step number 3, we need to find angle of asymptotes and centroid. What do you mean by angle of asymptotes? What do you mean by asymptotes? Asymptotes are just straight lines. They are just straight lines. Here we got 3 poles, P1, P2 and P3. Therefore, there will be 3 asymptotes. Now, what is centroid? Centroid is the point from where asymptotes start. For finding angle of asymptotes, the equation it is 180 into 2q plus 1 divided by n minus m, or we can say p minus z. In some textbook it is n minus m or p minus z. P is the number of pole and z is the number of 0. Now what is q? Q equal to 0, 1, 2 up to n minus or p minus z minus 1. We have plus or minus here. Okay, this is the equation for finding angle of asymptotes. Now we can find angle of asymptotes. First of all, we need to find the value of q. For this question, q it is 0, 1 and p minus z minus 1. We have 3 poles. We already found we have 3 poles. Then we have 1 0 and it minus 1. So 3 minus 1 it is 2. 2 minus 1 it will be 1. The values for q are 0 and 1. 0 and 1. Okay. Now when we have q equal to 0, the angle of asymptotes it is going to be plus or minus 180 into, instead of q it is 0. So 2 into 0 it is 0. 0 plus 1 it is 1 divided by p minus z. Number of poles it is 3. Number of zeros it is 1. So 3 minus 1 it is 2. 180 into 1 divided by 2. It is going to be 90. So the angle it is going to be plus or minus 90 degree. Now when we substitute q equal to 1, the next q value it is 1. We substitute 0, then substitute 1. When we substitute q equal to 1, that is plus or minus 180 into 2 into q. Q it is 1. So 2 into 1 it is 2. 2 plus 1 it is 3. So 180 into 3 divided by number of poles it is 3. Number of 0 it is 1. So 3 minus 1 it is going to be 2. So 180 into 3 divided by 2. 90. 90 into 3 it is going to be 270. So the value it is plus or minus 270. These two are the angle of asymptotes. Thus we got the angle of asymptotes as plus or minus 90 degree and plus or minus 270 degree. Now we need to find the centroid, from where these angles are going to be starting. For finding centroid, the equation is, the equation it is sum of poles minus sum of zeros divided by pole minus 0. Number of pole minus number of 0. Okay. Sum of poles. The poles are these 3. Sum means 0, then minus 2 plus 2.64 I or j, imaginary part. Then P3 it is minus 2 minus 2.64 I. This is sum of poles minus sum of zeros. We have only one 0, that is at minus 9. So minus 9, that is our 0. All divided by number of pole minus number of 0. Number of poles it is 3. 3 minus number of zeros it is 1. 3 minus 1 it is 2. Now here it is plus, here it is minus. So these two will get cancelled. Minus 2 minus 2 it is going to be minus 4. Therefore minus 4 minus and minus it will become plus. So minus 4 plus 9 divided by 3 minus 1 it is going to be 2. Minus 4 plus 9 it is 5. 5 by 2 it is going to be 2.5. Therefore our centroid we will denote it with sigma. Okay. Centroid is at plus 2.5. Now I will tell you why we are drawing asymptotes. Okay. Here the number of poles are 3. So there will be 3 asymptotes. But we already found, listen carefully, okay. Always root locus is going to start from pole and it is going to end at either 0, or if there are no 0 it will end at infinity. Okay. Always root locus will start from pole and it will end at either 0 or infinity. So we already found we have a root locus here. Using test point we found we have a root locus here. So root locus will start from pole and it will end at infinity, end at 0 or infinity. Here we have a 0, so it is going to end at this 0. So from one pole root locus start and it end at 0. Now we have two more poles, but there are no more zeros. So from this pole root locus will start and it will end at infinity because we don't have any zeros. It is going to end at infinity, but we don't know the path. For finding that path we are using asymptotes. So here two more poles are there, so we need two asymptotes. One asymptote is already over. Here three poles are there, so there will be three asymptotes. One asymptote, it is already over. Then there are two more poles, so we need to draw two more asymptotes. For drawing asymptotes we need angle of asymptotes. The asymptotes are going to start from centroid. For that purpose we are finding centroid. So the centroid it is at plus 2.5. 1, 2, 2.5. So this is the centroid. Now angle of asymptotes, it is plus or minus 90 degree. From centroid draw a straight line. Asymptotes are always straight line. From centroid draw a straight line plus 90 degree, that means perpendicular. Then minus 90 degree, that is also perpendicular. You need to use a protractor here, okay? Suppose sometimes you will get plus or minus 60 degree here or some other angles. At that time you need to use a protractor and you need to find or plot the line. For asymptotes always, please be careful, always we need to represent it using dotted lines. Now the root locus is going to go near to the asymptotes. It will go near the asymptotes. For getting the path of root locus we are drawing asymptotes. Now plus or minus 270 means same itself. Plus 270 means this line. Minus 270 means this line. If you use a protractor we can get that. 90 and 270 are same. We found that centroid is at 2.5. At 2.5 we have centroid, that is sigma. So we can denote that here. Centroid is at 2.5. Now angle of asymptotes are plus or minus 90. That we need to draw asymptotes, we need to draw using dotted lines. So plus 90. In dotted lines we need to draw asymptotes. So by using dotted lines, this is plus 90 and this is minus 90. And the same here, this is minus 270 and this is plus 270. So this is the angle of asymptotes. Now this is the asymptote and the angle of asymptote is plus or minus 90 degree, or this is the minus 90 degree. So this is the angle of asymptote. So we have centroid at 2.5 and angle of asymptotes plus or minus 90 and 270 degree. Then this is the asymptotic line. Now in step 4 we need to find breakaway and break-in point. What is breakaway and break-in point? Suppose think that in this question it is not there. Suppose think that you have adjacent poles. Always root locus is going to start from pole. So from here also root locus will start. Here also it is starting, here also it is starting. So it will meet at a point. That point is breakaway point. 0 means the root locus will start from a pole and it will end at 0. So it will end at 0. At a point it will break in. The root locus will come from somewhere and at a point it will break in, and here it will end this side and this side. So there will be a break in point. When there is adjacent zeros, break in point. When there is adjacent poles, breakaway point. So in this question, here there is a pole and here there is a 0. So there is no breakaway or break in point. If suppose there is a pole here, then here there is a pole, here there is a pole. At that time there will be breakaway. But in this question there is no breakaway or break in point. In the previous video I explained how to find breakaway and break in point using characteristic equation. Please watch that video. In this question there are no breakaway or break in point. In step 5 we need to find angle of departure. What do you mean by angle of departure? If there are complex pole, this is a complex value, real part and imaginary part, that is complex number. If there are complex poles, then there will be angle of departure. If there are complex zeros, in this case there are no complex zero. Suppose think that there is a 0 like minus 2 plus 3j, then it is a complex 0. At that time there will be angle of arrival. Okay, why angle of arrival? To 0 the root locus is arriving. From poles root locus is departure. The departure process is happening, leaving. From poles leaving. To 0 it is coming or arriving. Therefore if complex 0 is there, angle of arrival. If complex poles are there, then angle of departure. So in this question, there will be angle of departure. We already found the path of this root locus, that is from this pole, the root locus will start and it will end at this 0. But from these two poles, we don't know how the root locus is going to go. For that purpose, we have angle of departure. We can find by how much degree the root locus is going to turn from this pole. For finding angle of departure, you need to consider the complex poles. This one and this one are the complex poles. Okay. So I'm going to take this complex pole, the positive one. Okay. For getting angle of departure of this complex pole, draw or find the angles this complex pole make with the remaining poles and zeros. Okay. For getting, I'm going to first of all find this pole. Draw a straight line. The angle it is this pole going to make with the complex pole, it is, I'm going to name it as theta 1. Okay. Now this pole is going to make an angle with this pole. So the angle, if I keep a protractor here, the angle it is going to be 90 degree. I'm going to name it as theta 2. Now this 0 is going to make an angle with this pole. That angle it is going to be theta 3. For finding angle of departure, the equation it is 180 minus sum of angles the complex pole make with the remaining poles. So remaining poles are these two. That is, for this pole the angle it is theta 1. For this pole the angle it is theta 2. So theta 1 plus theta 2. Then plus sum of angle the complex pole make with remaining zeros. Here there is only one zero and the angle it is theta 3. So we need to find theta 1, theta 2 and theta 3. This is the complex pole. This is the complex pole P2. From this complex pole, we need to draw a straight line to all poles and 0. So to this pole, I am going to draw a straight line. Then to this pole, so this is the angle theta 1, and to this pole, I am going to draw a straight line. This is the angle theta 2, that is 90 degree because it is a perpendicular line. Now to this 0, we are going to draw straight line, and that is the angle theta 3. Now we need to find theta 1 and theta 2 using protractor. For getting theta 1, place the protractor here, then measure the angle. We will get it as, this is 120, so we will get the angle as theta 1, it is 127 degree. Now theta 2, we already know this is 90 degree perpendicular. So theta 2 it is 90 degree. Now theta 3, if you keep the protractor here, so this is theta 21. So theta 3 it is going to be 21 degree. Finding these theta values from the graph sheet using protractor, you can find the theta values, or you can use the tan method. For finding this theta 3, tan theta is opposite by adjacent. Opposite side, the height it is complex value 2.64. So 2.64 divided by adjacent value. Here it is minus 9. Here it is minus 2. So the remaining value it is 7. So 2.64 divided by 7. For finding theta, tan inverse this value. From that we can get the value theta. But simply from the graph sheet you can use protractor and find the angles. That is more easier. Now suppose in the question if they are asking us to find the angle of arrival, how to find that? The equation it is 180 minus sum of, we need to take complex 0 at that time. Okay, we need to find the angles the complex 0 is going to make with remaining zeros and remaining poles. Okay, so the equation it is 180 minus sum of angles the complex 0 is going to make with remaining zeros. First of all we need to take zeros, that is theta 1, then plus sum of angles the complex 0 is going to make with remaining poles. We need to take that values. Okay, like that. If it is complex pole we are taking, then we need to first of all find the angles that it is going to make with pole, then angle that is going to make with 0. If we are going to find angle of arrival at that time, for complex 0, the angle it is going to make with zeros here, then plus the angle it is going to make with poles. Hope you understood. So from the graph sheet we will get the values for theta 1 it is 127 degree plus theta 2 we already know it is 90 degree plus theta 3 the value it is 21 degree. So the answer it is going to be minus 17 degree. So at minus 17 degree the root locus is going to depart from this pole. Keep a protractor here, then take minus 17 degree, minus 10, minus 15, minus 17, it is going to be here. Okay, so by using this as the baseline, and here this is the 70-degree angle, so from pole the root locus will start and it will go like this. Then we have angle of asymptotes here, then it will reach the asymptote through imaginary axis. Therefore we need to find the crossing point. It is going to cross this imaginary axis. So that is the next step. We took complex pole, this one. By taking this complex pole we got minus 70 degree. So for this complex pole it is going to be plus 70 degree, the opposite. Now for drawing angle of departure we took the first complex pole. So first of all draw a straight line. For this is the baseline for keeping protractor. Then keep the protractor there. Then you need to take what angle? Minus 70 degree. 0, 10, 15 and here it is 70. So draw a straight line. This is the reference line for drawing. Okay, 17 degree. And for this complex pole, if this is minus 70, for this pole it is going to be plus 70. So again draw the reference line. Keep the protractor here. Then draw plus 70. 0, 10, 15 and plus 70 here. So this is the reference line. This is the angle of departure. Here it is plus 17 and here it is minus 70. Now in step 6, we need to find the crossing point on imaginary axis. On the imaginary axis, the root locus will cross. We need to find that crossing point. For that, we need to find closed loop transfer function. The question is our open loop transfer function. From open loop transfer function, we need to find closed loop transfer function. How to find that? Closed loop transfer function it is g divided by 1 plus gh. It is unity feedback. Therefore, h value it is 1. G value it is the question itself. That is k s plus 9. This is our g value divided by 1 plus again g value. G value it is the question itself. Now here it is 1. So do the cross multiplication. Now we will get the same denominators. So cancel it. Then the final answer we are going to get is k divided by s plus 9 divided by this thing. From this we need to find the characteristic equation. What is characteristic equation? The denominator is the characteristic equation. So this is our denominator and this is our characteristic equation. Denominator is the characteristic equation. Equate that to 0. Now open this bracket. We will get s into s square. It is s cube plus 4s square plus 11s plus ks plus 9k equal to 0. Now two methods are there to find crossing point. One is substitution. That is wherever there is s, you need to substitute j omega. Then we need to find the real part and imaginary part. That is one method. The another method is Routh-Hurwitz stability criteria. I will do both of that. Okay. First of all, we can substitute s equal to j omega. Wherever there is s, you need to replace it with j omega. So when we substitute j omega, we will get like this. Now we know j square. J square it is minus 1. So this term it will become minus 4 omega square. And j cube it is minus j. Therefore this term it will be minus j omega cube. J cube it is minus j. So it will become minus j. Then omega it is omega cube itself. Now we need to equate real part and imaginary part. Wherever there is j, it is the imaginary part. So this one and this one, it is the imaginary part. Real part it is, here there is no j and here there is no j. So real part it is minus 4 omega square plus 9k equal to 0. From this we will get 9k equal to 4 omega square. Now when we equate imaginary part, that is minus j omega cube plus 11 j omega plus k j omega. J is common. J means the imaginary part. Take that j outside. Then it will be minus omega cube plus 11 omega plus k omega equal to 0. J is the imaginary part. So this is the imaginary term. Equating that to 0, we will get omega minus omega cube plus 11. Here omega is common. So I am going to write 11 plus k omega equal to 0. Minus omega cube I am going to take it to the other side. So it will become 11 plus k omega equal to minus omega going to that side, it will become plus omega cube. Now omega and cube will get cancelled, we will get omega square. So we will get omega square, it is 11 plus k. Substitute here. So we will get 9k equal to 4 into, instead of omega square we can write 11 plus k. From this we will get 9k equal to 44 plus 4k. From this we will get 5k equal to 44 Therefore, k value it is 44 divided by 5, that is 8.8. Now for getting the value of omega square it is 11 plus k. K value it is 8.8. So 11 plus 8.8, it is going to be 19.8. Therefore, omega is root of 19.8. That is plus or minus 4.4. So omega value is our crossing point on j omega axis. So 4.4 is the crossing point. So we found the value of omega, that is crossing point on omega axis, that is 4.4. So 1, 2, 3, 4. At 4.4, it will cross, root locus will cross the imaginary axis. Now the second method to find the crossing point on imaginary axis, that is RH method, Routh-Hurwitz method. This is the method that I like the most. So if you don't know how to do Routh-Hurwitz, just watch the video on the description. Now the power of S is 3. So s cube, s square, s raised to 1, s raised to 0. Take the alternate coefficients. S cube, the coefficient is 1. Here it is 11 plus k. Now below that, here s square, the coefficient is 4. And here it is 9k. Now do multiplication like this. So 4 into 11 plus k minus 9k into 1. It is 9k divided by the starting element. It is 4. That is equal to 44 plus 4k minus 9k divided by 4. 4k minus 9k, it is minus 5k. So 44 minus 5k divided by 4. So this term it is going to be 44 minus 5k divided by 4. The last term is same. For the equation, the last term it is 9k. So here also the last term it is 9k. Now, in order to get the k value, equate this term to 0. So 44 minus 5k divided by 4 equal to 0. From this we will get 44 minus 5k equal to 0. We will get 44 equal to 5k. From that we will get k equal to 44 divided by 5. That is 8.8. After finding k value, we need to find auxiliary equation. What is auxiliary equation? Take the equation just above this term, take the equation. So here it is 4, here it is s square. So 4s square plus 9k. 4s square plus 9k equal to 0. From this we will get 4s square equal to minus 9k. What is k value? It is 8.8. So minus 9 into 8.8. That is minus 79.2. So we will get 4s square equal to minus 79.2. From this we will get s square equal to minus 79.2 divided by 4. That is equal to minus 19.8. So s square equal to minus 19.8. From this we will get s equal to root of minus 19.8. So root of minus 9 minus value. Therefore j will come. Then plus or minus root of 19.8. Root of 19.8, it is going to be plus or minus 4.4. Now we found the crossing point of on j omega axis, it is 4.4. This is 4. So 4.4 it is here. Plus 4.4 it is here. And minus 4.4 it is here. So the root locus will cross imaginary axis at this point. So root locus will start from pole, and here there are no 0. So it is going to end at infinity. From pole it will start, then it will depart through this reference line or angle of departure line. Then it will go to the crossing point. Crossing point it is 4.44. Then it will go along the path of asymptote to infinity. It will go parallel to the asymptote to the infinity. So this is the root locus path. Here the root locus will start from pole, then it will go through the angle of departure line, then it will meet the imaginary axis at minus 4.4. Then from here onwards it will follow the asymptotic path. It will go parallel to the asymptotic path. So this is the root locus at this region. So it will start from pole. So the arrow mark will be like this. It will end at infinity because there are no zeros. So starting from pole and end at infinity. The root locus will be symmetric to the real axis. This is the real axis. It will be symmetric, same on the positive side and negative side.